All right, welcome to 3-3, rate of change and slope. So, rate of change. All right, what is this thing? Well, first of all, we need to know what is change. What does change mean, right? That seems like a really simple thing, obviously, right? So, notation-wise, just so you guys keep this in mind, that little triangle there, that always notates a change in some quantity, right? And we did kind of with change with percentages also. We do the new value minus the old value to find the difference, right, between them, and that tells you how much did this thing change, right? You can think of money, you know, oh, a water bottle was $5, and then the price went up 3 years later, and it now is $7. What's the change? Take the difference, right? So you can kind of keep that in mind. Now, rate of change. Rate of change. What is this? So remember, a rate is just a relationship between two quantities, right? Similarly to our ratios, right? Ratios. A rate is another way of explaining a relationship between two different types of things, right? Two different quantities. So I have it here. We call it M. All right, and the rate of change, and we have the change in one of the quantities over the change in the other quantity, right? Okay, because we're relating the change, right? I want to see what is the relationship between the change in the first quantity and between the change in the second quantity. So we basically can set up a ratio for this. So how do we calculate that? Take a look. So we take our new values, subtract from the old value, and then we take the other new value, subtract it from the other old value, like that. Okay, and then with points, we talk about on the this will make more sense with more examples. We're going to go over it in 1 second, but with points, we take the change in the value. So we take the new minus the old, right? Change in the y values. The change in the y values would be the new y minus the old y. Change in the x values would be the new x minus the old x, right? And that also correlates to the slope of a line. And we'll talk much more about that. So let's just start with rate of change, though. Here we go. So a runner jogs 3 miles in 23 minutes, then continues on. She completes 5.25 miles in 52 minutes. What is the rate of change between her first pit stop and the finish line? Okay, so this seems like a lot of information, but really we have a couple of things. We have new and old, right? New and old. So what would we say is the new information? This would be a good time for you to kind of pause the video, right, and think about this for yourself, right? What's the new and what's the old stuff here? Okay. So the new is the further distance. You can think of it that way. She went the 3 miles at first, but then kept going for the 5.25 miles. So this is a new piece of information. That's maybe our further point, right? And then, so our other new would be 52 minutes, right? So our new stuff, we have two different new quantities. We have 5.25 miles, and we have 52 minutes. Right, so these are different quantities, but they're changing, right? So between miles and minutes, right? So then, and what's the old stuff? The old stuff is, well, the miles was 3 miles. So that's 3 miles. All right, so 3 miles changed to 5.25, right? And then the other one is 23 minutes, right? 23 minutes changed to 52 minutes. So how do we calculate this? First, let's calculate the change, right? Let's calculate the change. Okay, so I could do like change in miles. And what does that equal to? Change in miles would be new minus old, or 5.25, right, minus 3. Okay, and then we also have change in minutes. And what's that change? Well, same kind of thing. New minus old. We had 52 minutes, then minus the old value, or the further the beginning, closer toward the starting line, right? 23 minutes. Right, and then we just, you can throw that stuff in your calculator, really quick. So we can do like 5.25 minus 3 is, let me change to black. So we are good. That's 2.25, and we're talking miles. Miles. And then the other one, you can do this stuff in your head. 52 minus 23. Okay, that's equal to 29 minutes. So now the rate of change is simply a relationship between the miles and the minutes. So let's do that. All right, so your answer is simply 2.25 over 29. Okay, relationship between the miles and the minutes. All right, and then we can put that in a calculator and get a decimal for it. So 2.25 divided by, right, 29. And what does that equal to? Oh, it's about 0.08. And what would that be? That would be, then if we keep our units, we would say 0.08 miles per minute. And we could change our units to miles per hour too, right? If we multiplied by 60, right? But this would be miles per minute, and there's your final answer. So notice here, really quickly, we'll come back to this in 1 second, but we could be making a point out of these quantities too, right? And we'll do this with points right here. So let's go to the next example. Okay, so find the rate of change between 2 points, right? So we've got let's do this. These colors here first, right? Okay, so this would be new. Sorry. Hold on. Let's back that up. 1 second. Back that up. All right, we got to choose a new and we got to choose an old, basically. So I could say, all right, the second one. This is my new one, maybe new. And the first one I'll say is my old. So maybe I started here, right? I started at this point and then I went to that point. Think of it like that. Right, and then so we take the difference is all we do. So 5. We're gonna go change in y. I'll write the formula. Change in y over change in x. All right, so we've got change in y is going to be the new y first, right? So maybe we can do two colors, a green for y. How's that? Green for y, and then I'll do like purple for x, because I think colors are nice. So I'll go ahead and underline purple. If you guys are at home, use your colored pencils too. It's going to save your life. So there's our y values are green. So change in y. So our new. So that's going to be our 4, right, is our new value, minus 3, our old y value. And then that's going to be over our purple x's, but the new x, 5, minus the old, careful, use your parentheses here, the old value was -2. We're still minus -2, right? Yeah, so watch that. We have minus -2, right? Because we're still taking the difference, even though that value is negative. It's going to be minus that negative value, right? Okay, so what do we end up getting? On the top, we've got 4 minus 3. Okay, that's pretty straightforward. That's 1. And on the bottom, we get 5 minus -2, which is minus the negative is a positive. So 5, 6, 7. 1 over 7. So this is our rate of change. This is our rate of change. We call this thing m. It also relates to the slope of a line, which we'll go into more later, but for now, let's just start with rate of change, right? So let's move on to the next problem. Try it out here. All right, so again, we want to figure out which one do we want to call our new one. Well, I'll just call the second one new, right? So this would be new. And then our first one, we can call it our old point, right? And you can graph this stuff, and it's actually really nice to graph it. We'll do it later. Oh, I'm going to use red for sure, though. Red for that one. Good. Here we go. So that's our old point. Okay, so again, same steps. Let's find our y values. Let's not mix these up. So you go ahead and use your colors if you want. Y values, x values. There we go. And we just have to put them in the right order. Change in y over change in x, right? Y, the new value minus the old value, right? All right, so let's see what that is. So for our y's, we're going to get our new value was -1. Our old value was -7. But careful, it's minus -7. And I'll write that even more clearly. It should look a little better here. Minus -7, right? So watch your negatives here. You know, just be sure you keep your stuff in parentheses. You know, to not get yourself mixed up. Change of x, 4 minus 0. There we go. Okay, simplify this thing up. And here's how it looks. Remember, the minus, a negative turns to positive, right? Minus and negative is a positive. So -1 plus 7, different sign, take the difference, right? So that's going to be 6 over 4. 6 over 4. And that's our slope. Our slope, or our rate of change. Again, we're going to talk more about graphing, but first thing is just finding. So, going back to this example, if you take a look, and I reminded you, or I kind of briefly mentioned, if you look at this, what we're doing, the whole point of this is that what we can do is kind of boil this thing down, and this whole problem down into like small little pieces. So we just what we're going to do is just call this a point, these miles, comma, minutes, right? So this would be a point, and this would be another point, right? So that's the whole thing with math, is we're going to take, real world stuff and try to abstract it or change it into like the math kind of language so that we can manipulate it and play around with it easily and quickly. So yeah, anyway, practice that up, and hopefully that was helpful.